Today we are continuing our look at relationships, and we're focusing on discrete and continuous data today. So if you'll write that in the topic section of your notes as well as today's date. And this will be page number 10 of Unit B. And so on the front of your note sheet, there is a table where we are going to compare the difference between discrete data and continuous data, focusing on how that looks in the domain. So by definition, when we're talking about a discrete domain, that is referencing a set of input values that consists of only certain numbers in an interval. And so we're going to look at this in terms of a definition, what that means with words, how that looks in a table, and as well as in a graph. And then we're going to look at both of the situations in real life situations that may happen. So make sure that you copy the definitions down on your note sheet. So the difference between a discrete domain and a continuous domain is that a continuous domain consists of a set of input values that have all of the numbers in an interval, whereas the discrete domain is focusing only on certain numbers in an interval. So when we look at this in some word type of examples, a lot of times you can think of discrete data as being something that you can count, whereas continuous data is often measured. So you can have parts of something, whereas discrete data are usually your whole numbers and things that you can physically count. So it can include integers from 0 through 4, and these are just examples, so it doesn't always include integers from 0 through 4, but just an example of that. And so on the counter aspect with a continuous domain, that would be all numbers from 0 through 4, so including fractions, decimals, everything is included. So an example of a discrete domain would be the number of books in a library. So that would not be continuous because you cannot have half of a book or a third of a book. So you would have either 0 books, 1 book, 2 books, and so on. So that would be a discrete domain. Whereas a continuous domain here would be gallons of water in a puddle. So yes, we count gallons by whole numbers, so you have 1 gallon, 2 gallons, but it also increases and decreases with fractions of a gallon, pieces of a gallon that are continuous as it's inputting into the puddle or draining out of a puddle. So when we look at tables, so if we're looking at a number in a group and the cost of tickets, so if you have 2 people, the ticket cost would be $15. If you have 3 people in a group, your ticket cost would be $22.50. So this would be discrete domain because you cannot have half of a group member or a third of a group member or a fourth of a group member or so forth. So these would be only whole numbers that you can count the people in your group. Whereas on the opposite side, if we're talking about a continuous domain, so if we have the number of years and the height of a tree, so here we see that the number of years are whole numbers, so 0, 1, 2, and 3, but there is the time in between those years that you can include. So as the days go by, the hours go by, the minutes, the seconds go by, you're still including that in your domain. So it would be continuous. You don't just jump from year 0 to year 1. It's continual as the year progresses. Same from year 1 to year 2. You don't just jump a year in advance. You have all of that time in between. And so what this looks like in terms of a graph, so it says a discrete graph is a graph composed of distinct isolated points. So make sure that you write down this highlighted portion on your notes sheet. So composed of distinct isolated points. So on the number line, we have the point 0, 1, 2, 3, and 4. Whereas a continuous graph is a graph that is unbroken. So you can see that we have the point 0 and 4 and all of the points in between. So the discrete graph didn't include any points in between 0 and 1. It included 0 and 1 specifically, whereas here you have all of those points. So that is using a number line. So if we have a coordinate plane, we can see that these points are graphed here at 0, 1, 2, 3, 4, or as ordered pairs 0, 0, 1, 1, 2, 2, 3, 3, and 4, 4. And with a continuous graph, we can see that we have the points at 0, 0, and at 4, 4, and a line connects those points because it includes all of those pieces in between. So when we're looking at graphs and data and situations, it's important to recognize if it is based on a discrete data or discrete situation or continuous data, continuous situation. So in looking at this situation, we have two situations on the back side of your note sheet. The first one says the function m equals 50 minus 9d represents the amount of money m in dollars you have after buying d DVDs. So then we are going to graph the function and we are going to determine if the domain is discrete or continuous. So one of the first things we need to consider here is what our dependent and our independent variable is. So if we're talking about the amount of money, and also the number of DVDs that we have or after we buy, so we need to determine which one is dependent and which one is independent. So do the number of DVDs depend on our money, or does the amount of money depend on the amount of DVDs that we buy? So going back to those lessons that we've talked about before, so our independent variable would be our number of DVDs. And so then that would leave our dependent to be the amount of money we have left. So when it gives us the equation, then all we need to do is plug in some value. So we'll start with if we buy 0 DVDs, and we'll use whole numbers. So if we buy 1 DVD, 2 DVDs, 3 DVDs, 4, and 5. So that way we can get some data. And since it gives us our equation, then we just need to plug our value in for D, and it will give us our value of M. So our equation says M equals 50 minus 9D, and since our D value here is 0, order of operations 9 times 0 is 0, so 50 minus 0 would give us a value of 50. So we'll plug in those values to fill in our table. So M equals 50 minus 9, and if we bought 1 DVD, we'll find the cost. So 9 times 1 is 9. 50 minus 9 would give us a value of $41. So we would have $41 left if we bought 1 DVD. So continuing our table, so 50 minus 9 times 2 is 18, so that would give us a value of 32. M equals 50 minus 9 times 3. So 50 minus 9 times 3, 9 times 3 is 27, and take that from 50, so we would have $23 left. Nine times 4 is 36, so 50 minus 36 would give us 14. And last value, 50 minus 9 times 5. 9 times 5 is 45, so take that from 50, so we would have $5 left. So then also building on our first lessons that we talked about independent and dependent variables, we recall that our independent variable goes along our x-axis, so we'll have our number of DVDs along the bottom, along our x-axis, and the amount of money left will go along our y-axis, so that's our dependent variable. So also make sure that you set up your graph correctly. So it should look something like this when you have set that up. So go ahead and fill out your graph and pause here for a moment if you need to. And then we're just going to plot our ordered pairs. So if the number of DVDs, recall, is our value of x, or our x value, and the amount of money left is our y. So this would make our ordered pair. So we would have the ordered pair of 0, 50, and plot a point there. The ordered pair 1, 41, so it's not going to be exact, but we can ballpark a little bit above 40 and make a point. The point 2, 32, so a little bit above 30. Point at 32. And 3, 23, so above 20 but less than half of the way between 20 and 30. 4, 14. And then 5, 5. So just right in between 0 and 10 the best we can. So now we need to decide, do we need to connect these points and make this a continuous graph, or is this a discrete graph where the numbers that we're looking at are just the whole numbers that we're talking about? So what we're going to base this on is what our domain is. And so our domain in this case is the number of DVDs. So then we need to determine, okay, can we have between 0 and 1 DVDs? Can we have between 1 and 2 DVDs? Do we need to draw the line here to connect those to include all of those points in between? And so hopefully we should be thinking that we cannot do that. And so in this case, we would leave our points the way that they are. And we could say that the domain is discrete because you cannot buy part of a DVD. So the domain is discrete because you cannot buy part of a DVD. So we would just leave our graph. So we don't draw a line to connect the points. There are no arrows. We can just leave it the way that it is, especially in this case. There are some situations that this trend would continue, but if you notice here that we're going to run out of money. So that's when our graph would end here. So make sure that you copy this down before you move on. Let's look at another example. So if we have the function c equals 100b that represents the amount of calories c consumed by the number of bars eaten b, graph the function, and then we're going to ask the question, is the domain discrete or continuous, and hopefully be able to answer that question as we continue. So when we're identifying our independent and dependent variable, we want to consider what depends on the other. And so in this case, we are comparing the number of bars eaten and the calories that we would consume. And so our calories consumed depend on the number of bars eaten. So our independent would be the number of bars. And then our dependent are the calories. And since it gives us the formula up here as well, we'll just use that to gather some data. So we'll plug that into c equals 100b. So let's say that we don't have any of the bars. We'll go if we have 1 bar, if we have 2 bars, if we eat 3 bars, 4, and 5. And so we'll plug this information into the formula. So the calories equals 100 times the number of bars that we eat. So there are 100 calories per bar. So if we have 0 bars, then we consume 0 calories. If we consume 1 bar and it has 100 calories, so 100 times 1 would give us a calorie intake of 100. And continuing our table. And so we can see a pattern here as well as we find the calories per bar. And then we'll be ready to set up our graph. And so also going back to remembering that if we have our independent event, which is our independent variable, which is the number of bars, that is going to go along the x-axis, and the number of calories is our dependent variable, which will go along the y-axis. So go ahead and set up your graph. And then we will plot our points. And so if we have our x and our y to make up our ordered pair. So if we have 0 bars, we would have 0 calories. So a point here, a point at 1, 100, a point at 2, 200, at 3, 300, 4, 400, and 5, 500. So we have graphed the function, and so then it asks, is the domain discrete or continuous? So the example before was, okay, can we have 0 to 1 DVDs? And the answer was no. But here when we're talking about the number of bars or protein bars or cereal bars that you have, can you have between 0 and 1 bars? Can you have between 1 and 2 bars? And so the answer to this is yes, you can. You can have a part of a cereal bar. So we would then connect the points. This goes on forever. So we would have an arrow going up to the right. You have to consider and think about this, that we wouldn't have an arrow going down because you wouldn't have a negative value of bars that you've eaten. So that would just connect, it would start at the origin at 0, 0, and it wouldn't continue down to the left, but it would continue up considering if you had more than 5 cereal bars or protein bars. So in this case, you can eat parts of a, let's say we're having a cereal bar. So the domain is continuous. So make sure you finish taking notes and have filled in all the tables, graphs, and as well as these answering the question, is the domain discrete or continuous? Because that will be important as you work on your assignment today.